Hello students, today the lesson is about related rates, and before looking the complete video, kindly subscribe the channel so that you can get notifications about the new videos. So our success criteria is to find the related rates to solve the real life problems and also describe and compare the solution method. So firstly, it is very important to understand what related rates are. So whenever we talk about the related rates, it means we are trying to find out to find out the changes that take place among the quantities with respect to times. We can compare their solutions. We can compare the quantity's progress with itself, means whether it is increasing, decreasing, expanding, compressing by the time, or we can even compare that quantity with another quantity with respect to time. Now the question arises that how can the derivatives will be taken? So we will take the derivative using the implicit differentiations concept. What do I mean by that? So for example, if this is the x and you are asked to take the derivative of x with respect to x, means take derivative with respect to x. So how do you take the derivative with respect to x? You know that the derivative of x is constant. But when we ask you to take the derivative of y with respect to x, so what do you say? That derivative of y with respect to x is dy by dx. And what is d by dx actually? D by dx is actually the differential operator. So if you remember that for the differential operator, we use the symbol d by d operator. We use the symbol d by dx. Also, we use the symbol y prime, and sometimes we use the symbol f prime x, h prime x, k prime x, means the prime actually is the short form of d by dx. But now we are asking you to whatever the symbol you are, whatever the derivative you are taking, just take the derivative with respect to time. It means you are going to use the differential operator, which will be given as d by dt. And none of the alphabet will be considered as constant until they will specify that that particular alphabet x, y, z and whatever is constant. Otherwise, the function is the time and everything is changing with respect to time, because d by dt means the derivative and derivative means the rate of change. So everything is changing with respect to t or time. So how can we say that what will be the derivative of x? So the derivative of x can be written as dx by dt. Similarly, how can you take or write the derivative of y? So the derivative of y with respect to time will be written as dy by dt. Similarly, if I say that A is used to determine the area, means to denote the area. So how can we take the derivative of area with respect to time? I will write dA over dt. Similarly, if I say that R represents the radius, okay, so what will be the derivative of R? You will say it will be dr over dt. So you can see that none of the symbol or none of the alphabet has been taken as constant, and to take the derivative of those alphabets, you just add d by dt before them. You just add d by dt before them. Similarly, what would be the derivative of volume? It will be dv over dt. What will be the derivative of acceleration with respect to time? So it will be dA over dt. What will be derivative of side or edges of a cube? For example, if it is represented by s, so you can say it will be ds over dt. So I think that this concept is clear to you, that how can we write the differential operator before any alphabet if the power of that alphabet is 1. Let's revise one more time the concepts of derivative with respect to time using the implicit differentiation. So if I say that you have to take the derivative of everything with respect to time, it means you have to use d by dt operator. If this is the x, so the derivative with respect to time, you just said that it will be dx over dt. But what if x has a power? Let's suppose it's 3. So how can you take the derivative? So using the concept of implicit differentiation, you will bring the power in the shoulder, you write the variable from the power u minus 1, that will gives you 2, but it is not ended. Why? Because you are using the concept of implicit differentiation. After applying the power rule, you have to write dx by dt. It means the derivative of the inner function. So what will happen if I say that, for example, y to the power 8? How can we take the derivative using implicit differentiation concept? So it will be 8y to the power 7. It doesn't finish. You will write dy by dt. Again, for example, if you have the area a to the power 2, a square. So how can you write the derivative? So it will be 2a, and in the end you will write dA over dt. But normally the students, they forget to write the last thing. That means they forget to write the derivative of the inner function. So will that of course will not give you in the end the correct answer. So please do not forget such kind of and avoid doing such kind of mistakes. Now let's see. Now let's see what will happen if I have r to the power 3 and 1 over 3 r cube. How can we take the derivative of 1 over 3 r cube? Bring the 3 here, means multiply 1 over 3 times 3. Multiply 3 by 1 over 3, which will give you 1. Then write the r. From the power we subtract 1, it will gives you 2, but it doesn't end. You have to write dr by dt. Now let's apply the concept on after looking at the equation. For example, if I have an equation of the area of the circle represented by a equals to pi r square, how can you take the derivative? Now take the derivative on the left hand side and right hand side both. It means the derivative of a will be dA by dt equals to, now pi is a constant, so you have to use the constant multiple rule. Multiply 2 with the pi, so you will get 2 pi r. From the power subtract 1, so after that you have to write dr by dt. Let's solve few more questions. For example, if I have v equals to 4 by 3 pi r cube, this is the formula of the volume of a sphere. So how can we write it? We will say dv by dt on the left hand side equals to 3 times 4 by 3 pi. Why? Because this is all a constant number. So it will give you 4 pi. Use the calculator if you are weak in multiplication or the times table. So 4 pi, so this cancel, it will give you 4 pi r from the power v minus 1, so square, and in the end we will write dr by dt. So this is the way how we use our implicit differentiation. Now let's check one more thing. Let's suppose it is y equals to sine theta. You have to take the derivative with respect to time. So y, you will write dy by dt equals to sine theta. So here you will apply again chain rule along with the implicit differentiation. So derivative of sine is cos. Write the theta as it is and take the derivative of inner function with respect to time. You will get d theta by dt. Let's move to some more questions. For example, if I have y equals to, for example, a square times cos theta. So what have you seen here? Here you can analyze there is one symbol that is a and there is another symbol theta. Now what if you have the two symbols and none of the symbol is constant? So of course when two functions are given to you, you apply the product rule. First function, derivative of second function plus second function and take the derivative of first function. So let's start. The derivative of y will be dy by dt equals to first function as it is, that is a square, derivative of cos theta and with respect to time. So cos changes into negative sign. I write negative here. Negative sine theta and the derivative of theta, don't forget, that is d theta by dt. Then you have a plus g, that is cos theta, and then the derivative of a square. Same way, the derivative of a square will be what? 2a, that means the power rule, 2a, and in the end dA by dt. So I hope that this concept is clear, that when do we apply the product rule, when do we apply the constant multiple rule, and so on. Let's try to solve some example to clear our concept. Take a very easy example. Here they are saying, suppose x and y both are differentiable functions with respect to time and they are connected with the equation y equals to x square plus 3. When x equals to 1, given that dx by dt equals to 2. So what you have to do before applying anything, the given quantities, the given values on the quantities, first of all, you have to take the derivative. So derivative y will be given as dy by dt equals to the derivative of x square is 2x and don't forget to write dx by dt. Now 3 is a constant, so derivative of 3 is 0. Now look at the question again. Find dy by dt. It means write dy by dt as it is equals to the number 2 as it is. They are saying here that x equals to 1. So substitute 1 as x and dx by dt is given as 2. So replace 2 by dx by dt. Now just calculate, that will gives you the value of dy by dt as 4. Now one more thing which is very important to tell you, that how do we read in English language dy by dt. It is very important to understand that how do we read this thing. Some people says that take the derivative of y with respect to time. It's absolutely correct. But in order to analyze the word problem, you must know that they will not write take the derivative of y with respect to time. In the word problem, it will be written as rate of change of y. So if it is written like that, it means they are talking about dy by dt. And what is the rate of change? Which verbs can tell you that something is changing? So increasing, this is the state of changing. Decreasing, it is a state of changing. Fast or slow, these are the states of changing. Similarly, they can use the word expand, contract, stretch, compress. So these are some of the words which express the changes, rate of change. Let's solve one more question. Find dy by dt. Find dy by dt if they are related with the equation y equals to 1 over 1 plus x square, and given that dx by dt equals to 6 inches per second, whereas x equals to negative 2 inches. Now you have to take the derivative with respect to time. Now here it is very important to analyze the question before applying any property. Most of the students, they apply directly. They just see that this is written in the form of quotient. They apply the quotient rule and they become lost during solving the problem. Understand that whenever only one term, especially a constant term, is written in the numerator, constant is very important. It means there is a number written on the top and there is a function written in the denominator, then rather than applying the quotient rule, bring the whole equation in the numerator. How? You will write 1 as it is. Bring 1 plus x square is a complete equation. And if you look at closely, this equation, this bracket has 1 power. So when you bring it in the numerator, the sign of the power changes, that becomes -1. Now take the derivative using the chain rule. How? Bring the power in the shoulder, -1, write the bracket inner function as it is. From the power we subtract 1, it gives you -2. Then take the derivative of the inner function, which will give you 2x, and then don't forget to write dx by dt. Now replace all the things. So here I forgot to write the equation on the left hand side, that is dy by dt. So don't do mistakes with the mistakes which I did with here in front of you. So here 1 plus what is x? X is -2. So you will write -2 square and then whole square. Then 2, the value of x is -2 and dx by dt is its 6. Now solve. So -1, that will be 2 times 2 square means 4, 4 plus 1, 5. And here you will have 5 to the power -2. And -4 times 6, it will gives you -24. -24 times -1, it will gives you 24. And 5 to the power -2 will goes in the denominator as 25. So dy by dt equals to 24 over 25. If calculators are allowed, then write the whole equation over here in the calculator to get the answer. Try to solve another question. So find dy by dt when the equation is related in the form of y equals to 10x, dx by dt equals to 3 feet per second, and the value of x is -pi by 4 feet. How will you solve this kind of question? Okay, so first thing is that you have to take the derivative calculator. You have to take the derivative left hand side, that is dy by dt equals to derivative of tangent x is secant square x, and then write in the end dx by dt. Now once it is done, replace all the values. So secant square, now the value of the x is -pi over 4. Dx by dt is given as 3. But if you go to the calculator, you will come to know that there is no cursor for secant. So what is secant equal to? So secant x is actually the reciprocal of cos x. So how can you write in the calculator? You will write 1 over cos. The angle is -pi over 4. Don't write the square on the cos. In the calculator, you have to write overall square times 3. Use the calculator and get the answer. So I am also using the calculator. Kindly write down 3 divided by, in the bracket write cos -pi over 4 cos, and when you write the angle -pi over 4, please don't forget to write the brackets. Okay, close the bracket, put the square on the top, and your answer will be 6. But that make sure that you wrote everything in your calculator must be in radian mode. So here is our answer, feet per second. Now let's try another question. X and Y. What will happen if the two functions are written together? As I said before, when two functions are written together, we always use the product rule, according to which the first function derivative of second function plus second function times the derivative of first function. So first of all, take the derivative with respect to time. F is x, d prime means dy by dt, plus d is y, and f prime means dx by dt, and the derivative of 4 is 0. Now replace the values. X is given as 8, dy by dt you don't know, plus y is y's value is also 1. So take it y as 1, and dx by dt is equals to 10 and equals to 0. Now bring the 10 on other side. You will get dy by dt, 8 dy by dt equals to negative 10. Divide both sides by 8. So you will have the answer dy by dt equals to minus 5 over 4. So it is so simple if you just focus on the questions. We will continue in the next part and we will solve the real life problems in order to understand more about the related rate.